All right, we're back, or we're on page 3 of notes 27 from Calc AB. It's not actually a Calc AB topic. We do it after the AP exam. If you're in Calc BC, partial fractions is a BC topic, but only non-repeating linear factors, which is like the first and second videos, probably in the playlist, I hope, if I made a playlist. We're going to talk right now about how you can do this with a quadratic factor, mostly so you know it's possible. Then we're going to do a problem which, if memory serves, is pretty terrible. But we'll see just how bad it is. So with linear factors, we need a proper fraction. So what is the highest powered thing you can put over a linear factor and still get a proper fraction? So the degree needs to be less than the degree of the denominator, was a constant. If we have a quadratic factor, it's more complicated because what is the most generic thing that you can put over a quadratic? Well, it would be a linear, right? Because there could definitely be a linear. It's still a proper fraction. So we would want to look at something like ax plus b over x squared plus x plus 2. So if we had a cubic, for example, so a cubic, not x cubed, but a cubic factor, right? So like x cubed plus 10x squared plus 5 or something like that, right? So if we had x squared, x cubed, so good cubic example, x cubed plus 10x squared plus 5. Like the most generic thing we could put over that would be a quadratic, and that would be ax squared bx plus c. So this gets out of hand really fast, right? Because like for this cubic one, that's 3 unknowns we need to solve for. Potentially some of them will be 0, which is even worse. But for the quadratic, we have 2 unknowns that we need to solve for. So it's not great, but you can do it. So you just have to be organized. Cover-up method will not work for this. But if there are linear factors in the mix, it might work for those. So let's see if we can do this. All right, so I see the quantity x minus 1, that's linear, squared. So that's a repeating linear factor. So I'm going to say a over x minus 1 plus b over the quantity x minus 1 squared. All right, so we dealt with our repeating linear factor, same as we always do. Now we have this quadratic factor. So what could be over that? Well, it could be cx plus d. 4 unknowns. So fantastic. All right, and then this will be equal to the quantity x cubed minus 5 over quantity x minus 1 squared, x squared plus x plus 2. All right, so now what can we do? Well, I do see a linear factor. I can use the cover-up method on the thing that's over the highest power of that, so I can find b. So I might as well. So if I let x equal 1, I'm going to know that b is equal to, we go over here, we cover up this, and then every other x that we see is going to be 1. So that's 2 times negative 4 is negative 8 over 1 plus 1 plus 2 over 4. So b is negative 2. That's a nice easy start to the problem. All right. So now what can we do? Well, I still have 3 unknowns that I need to solve for. I need to solve for a, c, and d. So I could just choose 3 values of x, plug it in, and kind of hope for the best. Like, what 3 values might I choose? 2 seems like a pretty good choice because of the x minus 1s. 0 is always a great choice. And then maybe, I don't know, like any other thing, and just see if we get something that we can solve, maybe. Or we could try, let's clear the denominator. Let's just clear the denominator. Maybe we'll get some clarity by doing that. Maybe not, but so I'm multiplying both sides by the denominator of the right-hand side, which gives me, so I'll get x minus 1, x squared plus x plus 2 times a. B I know is negative 2, so negative 2. And then x squared plus x plus 2. And then the x squared thing the quadratic will cancel. So I'm going to get plus the quantity x minus 1 squared, and then cx plus d. And then that all equals 2 the quantity x cubed minus 5. All right, so I'm not like super stoked to do any of this, but I'm gonna pick some values. Let's just pick values. So I'm gonna say let's see. So if x equals 0, I could differentiate. I don't really want to do that because I feel like I'd have to expand first. All right, we'll do x equals 0, right? That's your go-to. If you can use 0, you should use it. So we'll get negative 2a is like all that's left there. Minus 4 is all that's left there. And then we get 1 times, so plus d equals negative 10. All right, not bad. So that's one equation. And we only have a, c, and d that we need to solve for. So that's one equation, two unknowns. Let's choose x equals 2 and hope that that's a good choice. X equals 2 gives me, so that's 1. 4 plus 4 is 8a. Okay, not like terrible. 4 plus 4 is 8 minus 16. You know what sometimes happens though? Like so far I have 4 times this. This might be a problem because I might just get 4 times the previous thing. Do I? No, I think I don't, but I was a little worried about that. So 2 gives me plus 2c plus d. 2c, yeah, plus 2c plus d equals 8 minus 5 is 3 times 2 equals 6. All right, I mean, I don't want to solve this, but like, I think I can. And then what's another choice? So should I go with -1? Like usually you want to keep them small because that's like a little easier. So I'm gonna use -1, and hopefully we get something usable. So x equals -1. All right, so I get -2. I get 1 minus 1 is 0, 2. So I have -2 times 2, so -4a. Feels like these are designed for you to cancel a out. I didn't design the question. I don't really know, but so it's 1 minus 1 is 0 plus 2, so -4. All right, let me check that again. 1 minus 1 is 0. 2 times negative, yeah, I think that's right. And then here I get -2, but squared is 4. And then -c, so minus 4c. And then 4 times d plus 4d equals, what do I get when I plug in -1? I get -1 minus 5 is -6 times 2 is -12. Okay, so this one completely simplifies, and that's kind of interesting. So let's do some work on each of these. So here I'm going to have -2a plus a d equals -6. Okay. This one, there's really not much that simplifies, but I mean, it does a little bit. Basically, right now, I'm like avoiding doing algebra, which is kind of sad. So 8a plus 2c plus d equals 22, I think. Or, I don't know. And then I can divide through by -4 or divide through by 4. So if I did that, I would have -a minus 1, and then it equals -3. So that's going to be, don't worry about those yet. Minus c plus d equals, all right, so now worry about it. -3, and I'm adding 1, so it equals -2. All right, so what can we do? What can we do? We can, I'm going to double, what am I going to do? I'm going to double the third one and add it to the second one. I don't know. So that's my go-to here. I'm going to double the second one, no, the third one. I'm going to label these. Here we go. 1, 2, 3. All right, my plan is I'm going to do 2 plus 2 times the third one. And if I do that, okay, so I'm doubling, so I get -2a, so it gives me 6a. I get -2c plus 2c, gone. I get 2d plus d plus 3d. And then that equals 22 minus 4 is 18. Oh no. What the heck? Did I just end up? I think I just ended up with equation 1 again. If I divide through by 3, I get, no, I didn't. Okay, that's not, okay. Whew, okay. So let's do, I'm going to triple number 1 and add it. And I think this should work. I don't really know. So I'm going to add 3 times number 1. This is sad, right? Like, the hardest thing about this problem, maybe, potentially, is actually solving for these things. And like, I'm just like avoiding doing the real work. But thanks for joining me on this journey. So, okay, so 3 times number 1, negative 6a plus 6a, gone. 3d plus 3d, so I get 6d equals, I have 18, so 0. Cool, so d is 0. And if d is 0, then a is 3. And if a is 3, so that was from, where was that from? That was from here. I'm gonna be really happy if I get this. And then, so I have a, I have d, I have, let's do this. We have a, we have d. We already knew, like 6 years ago, we got b. And now I think I can use any of them to get c, right? So from here, I would have negative 3 minus c plus 0 equals negative 2. Add 3, that gives you positive 1. So c is negative 1, I think. Okay, so I think that I'm going to try to integrate what? Okay, so a is 3. So 3, the integral of 1 over, it's great that I can't even see it, x minus 1. B we got was negative 2, so it's going to be minus 2. The integral of, I like to bring this up to the negative second. So those are straightforward. We can definitely do those. And then we got D was 0, but we got C is negative 1. So it's going to be minus the integral of x over x squared plus x plus 2 dx. All right, before we try to integrate, because that last integral is going to be not terrible, but like, I'm going to show you a thing. I'm going to expand the original and see if we got it. And if we didn't, I'm going to be so disappointed. Also, I'm probably going to delete the video and you'll never know that it happened. But I think you'd probably appreciate that because you probably don't want like a 50-minute video of this. 3 over x minus 1 minus 2 over that, and then minus, yes, we got it. All right, so next phase of the game, we're going to try to integrate this thing. So most of it's pretty straightforward. I would say 2/3 of this, very straightforward antiderivative. So this will give me 3 natural log absolute value of x minus 1. And then this will give me plus 2 over x minus 1. And then minus the integral of x over x squared plus x plus 2 dx. All right, so what do we do with this integral? Because this is weird, right? So let u equal the denominator. We're kind of like missing something, right? Like it would be 2x plus 1. You'd do the plus 1 minus 1 trick, but really you'd have to do like plus 1/2 minus 1/2 and then multiply one of them by 2 over 2. And it's like a little messy. So here's what I'm going to do instead. I'm going to do this integral up on the side. So, and like, don't forget it's minus that. So like, that's going to be a problem. I'm predicting that will be a problem when I forget to do it. So I'll do it in a weird color. So integral of x over x squared plus x plus 2 dx. We're going to complete the square. So to do that, we're going to have x. All right, so it's going to be x squared plus x. All right, coefficient of x is 1. Divide by 2, that's 1/2. Square it, that's 1/4. Add that and subtract it. So plus 1/4 minus 1/4 and plus 2 dx. So this is x quantity x plus 1/2 squared, and then plus 7/4. So 8/4 minus 1/4 is that, and then dx. Okay, now I'm going to actually do a u substitution. I don't usually actually do the u substitution. I usually just kind of like think my way through it. Not on this one. Let's let u equal x plus 1/2. Okay, so x is equal to u minus 1/2, and dx is du. All right, so now our integral becomes the integral of u minus 1/2 over u squared plus 7/4 du. All right, so why is that good? Well, it's not great. Also, I hate this color, so I'm going to switch this. Let's use a darker. I think that's like a neon green type situation. We can break this into two integrals. So u over u squared plus 7/4 du. That's going to be a natural log. You can like see it. And then minus, let's say 1/2 integral of du over, I'm going to make it 7/4 plus u squared. That's going to be an arctan. Whew. All right. So it's not like your dream scenario, but it's not the end of the world. So this will be, there should be a 2 and a 1/2. So 1/2, the natural log of the absolute value of u squared plus 7/4. I know that's always positive, but you should put the absolute value. Now, what do I want to do on this next one? Well, first of all, I'd like to have more room. A little room to breathe, you know? And then, all right. I'm going to factor set, I'm going to divide everything I see by 7/4, right? So I'll get 4/7 in the numerator, I'll get 1, and I will get 4u squared over 7. Okay, so what did I say I was going to do? So 4/7, I'm also going to factor that out. So negative 1/2 of 4/7 integral of du over 1 plus, I'm just going to go for it here, say 2u over radical 7 squared. All right, so this is 1/2 the natural log. You know, if you go way back, this denominator here, like right here, is the same as this denominator, which is the same as this. That's just x squared plus x plus 2. So I'm going to go back to that right now and say this is the absolute value of x squared plus x plus 2. And then this is minus 2/7. This will be, all right, so it's arctan where like w is 2u over root 7 or something. So I need a 2 over root 7, so a root 7 over 2. So root 7 over 2, tan inverse of 2u over root 7. 2u over root 7. I'm going to put a plus c. So can we like steal some of this? Do we have a final answer? I feel like we do. So u is equal to x plus 1/2. So I can convert a lot of this. I think I'm ready to write my answer. So my final answer is going to be, oh, I'm probably going to forget that minus sign. I'm going to copy this and paste it. So it's this minus, let's open a parenthesis here, because like, parenthesis. This thing is done, so I'm going to do the copy paste trick. This. Also, like, who even knows? Hopefully this is right. Paste that. Ah, that's not the right thing. Get out of there. What happened to my copy and paste? Copy you. Paste you. There we go. Okay, so it's really small. And then this one I'm going to rewrite. So I have negative 2 over 7, root 7 over 2. So I'm just going to make that negative root 7 over 7. I'm not sure why the minus is there, but I'll just trust the process. And then this, we said that u is actually this. Oh, that's gross. U is actually that. So 2 of those is 2x plus 1. So I'm going to make this tan inverse of 2x plus 1 over radical 7. And then how many parentheses? Let's close this and do a plus c. And then should we check that? I guess we should. I'm like filled with fear over this. This is a doozy of a problem. So integral of the answer with respect to x. What is this? Expand that or something. What is happening? That is nuts. That seems wrong. I don't really know. Is this even the right problem? Let's just integrate. Let's do the integral of the original, because that is definitely not what I got. I got like, what is all this? What's all this x minus 1 in the denominator stuff? 2x cubed minus 5. Or what if I have to resort to, I might have to, taking the derivative of my answer, which is not bad because the calculator is going to do it. But yeah, why are you doing this to me? Like, those cancel. I don't even know. I don't want to search this out. Let's try the derivative of, oh man. So 3 natural log, I'm just going to do x minus 1 because like I don't want to deal with domains, plus 2 over x minus 1 minus 1/2 natural log of, so it's going to be dicey because of the natural logs, plus 2. And then it's plus, I guess, the square root of 7. I could have graphed both my answers. That would have been a smarter thing to do. Arctan of 2x plus 1 over square. I'm just not looking for the mistake. I will redo this if this is not right. And then the derivative of that with respect to x. Denom of that. So 2, oh, what? Factor. 2 x cubed minus 5, x minus, yes! We got it. All right. Whew. So I don't even know. This feels like a 20-minute problem. Hard to say. Certainly the hardest integral that we will do in Calc AB, for sure. So I can't even get on one page. Here's the top half. Take your screenshots. Sorry that I use such gross colors on the right side there. And then here's the bottom half, and that's correct. So, see if you can follow it. Again, this is harder than it needs to be. There's almost no reason to do this particular problem. But anyway, that's basically all of partial fraction decomposition. So you got your linear non-repeating factors, repeated linear factors, nothing wrong with any of those. Quadratic factors just mess everything up. Sometimes you got to do this complete the square U substitution thing. I have a separate video on that if you're interested. It's like, I didn't know what to call it. It's like integrating 1 over a quadratic where the discriminant is negative. Like, the technique always works on those, but that's like a lot going on. So go look for that if you're really interested. Otherwise, thanks for doing the notes with me, and I will maybe see you in the next video, but I hope you're finding these helpful.